Hello there, welcome to this video. This is lesson 1 of unit 5 on rational equations. Today we're going to introduce rational equations and we're going to start to talk about the essential ideas in solving rational equations as well as problems in restrictions of domain when we want to go ahead and present a final solution to rational equations. So we're going to go ahead and focus today on learning how to solve rational equations with the specific focus of how do we factor a polynomial completely, how can we identify common factors, and as well as we'll be able to solve a linear equation. Concept and development vocabulary. A rational equation is an equation that involves at least one rational expression. And remember, a rational expression is when we have a variable in at least one of the denominators. And we can see a couple of examples here. We have 4 divided by 5x minus 2 over 7 equals 1 over x. Because there's variables in the denominator, that's a rational expression. And as well as our second example here, we have 3x over x plus 1 equals 2 over x minus 2 plus x minus 4 over x squared minus x minus 2. These are rational expressions, each of them, because they have a denominator that has a variable with it. Now, in order to solve rational equations, we're going to need a couple of ideas. The first one is the lowest common denominator. So just like when we wanted to add or subtract or combine fractions, because rational expressions are a fraction, we're going to have to talk about how do we find a lowest common denominator. The lowest common denominator is abbreviated the LCD, so you'll often hear it referred to that as that. But it is just a product of all of the factors that are shared or that are common between two or more of the denominators and any remaining factors. So we have shared and we have remaining. It's going to be very, very important when we're finding our lowest common denominator. I'll give you an example here. Here we have x minus 2 over x plus 6 times x minus 6 plus x over 2 times x plus 6 equals 3 over x. If we want to find the lowest common denominator, we're going to have to find what is a shared factor. So notice how they have an x plus 6 that is shared. That's going to be part of the lowest common denominator. And then we also have these other remaining or non-shared factors in the denominator. We have an x minus 6, we have a 2, and we also have an x. So those are, that's an example of the lowest common denominator. So let's specifically talk about the steps. Here are the steps in order how we find the lowest common denominator. Number 1, in order to find the factors, you got to first completely factor the polynomials. So what we're going to go ahead and do is we'll factor each denominator completely. Step 2, here's where we identify the shared and the remaining factors. Step 4, you're just going to write out the LCD, which is a product of the shared and the remaining factors. Let's go ahead and look at an example. Here is example number 1. We have 2 over x squared minus 9 minus x over x minus 3 equals 5 thirds. Step number 1 is to completely factor your denominators. Notice the first expression, 2 over x squared minus 9, that can be rewritten as 2 over x minus 3 times x plus 3, where that is difference of two squares. So we've factored, and these examples we're going to look at in this unit are mostly simple, so they'll be very, very straightforward, simple factorization. We've factored that. Okay, so step 2 now, here we're going to go ahead and we're going to identify what is shared. Which of these match? And it's essentially a go fish game. Don't look for parts. Remember, if you have parentheses, that's a factor together. So notice how I have an x minus 3 and an x minus 3. That's a shared factor. Now what is remaining, or what is left over? This is step 3. What is remaining? What is remaining? I have a 3 and I have an x plus 3. We have a 3, x plus 3. Okay, so step 4, your lowest common denominator for this example is 3 times x minus 3 times x plus 3. And how we order these right down here doesn't matter. Generally, you put the monomials, like terms that are just by themselves, like the 3 or a 3x, we put those in front. There's your lowest common denominator. Pretty simple, right? Okay, next example. Again, if you need to pause me at any time, feel free to pause me or slow me down. You're welcome to do that. But here's the next example. Again, step 1, I'm going to go ahead and I'm going to completely factor this. Now, notice my first expression, I have x plus 1 squared. What I'm going to do is I'm going to go ahead and I am going to expand that. Rather than leave it in exponential form, I'll expand it. And then we have x plus 1, x minus 1, and then we have 3 over x. So what is shared? Well, I have a shared x plus 1. Okay, shared x plus 1. And what I like to do over here is I like to write shared. We have x plus 1. Okay, nothing else. Nothing else that is shared. Notice this is an x, but this is x plus 1. This is x minus 1. So those are not shared. Okay, and then what is remaining? Remaining, or what is left over? I have another x plus 1. There's another in that term. So I have an x plus 1. Like I said, we have an x minus 1 and an x. Okay, so our lowest common denominator is x. I don't know why I put that parenthesis there. X times x minus 1 times x plus 1 times x plus 1. Okay? And if you want, you could condense this back to x plus 1 squared. So those are the same thing. Okay? Example 3. Here, hey, sometimes it's awesome. I don't have to factor anything. That's already taken care of for us. And then notice, is there anything that is shared? Any factors that are shared here? And the answer is no. I have an x minus 2. If there's an operation, that's one factor. So nothing that's shared. So what's remaining is our LCD. X times x minus 2. Sometimes it's very, very simple like that. Example 4, same situation. I don't have anything to factor, anything to break down. So our LCD, I have a 3, and we have an x plus 5. Do we care about the numerators at all in this process? The answer is no. I don't care what's going on in the numerators. I'm trying to find the lowest common denominator. Now we're going to use this later on. It will have a purpose. So, and the numerators will be important later on. So don't go home and tell your parents that numerators don't matter. Because they do. Don't post that online. Don't be a Twitter tough guy. Okay, hurt their feelings. Here you go. I want you guys, I have 3 practice problems here. I'll go ahead, I'll give you the opportunity to answer this. Pause me. Try this. Pause me. This is where you get feedback in a digital lesson. I'm going to pause this. Well, I'll ask you to do it. You do this, okay? And then pause me, and I'll come on with the answer, okay? All right, first practice one. Go ahead, try this. What is the LCD? All right, thank you for pausing me and attempting this. In this one, there's no factorization. No factorization, so we skip that step. We have nothing that's shared. No shared factors. So I hope you didn't say that any of this was shared. There's no shared factors. And then our LCD, this one's very simple. X times x plus 3. That's it. Pretty easy. Okay, here's example number 2. I call this example or this practice problem number 2. Okay, try this. Pause me. All right, thanks for trying this example. Step 1 here is applicable. Step 1, you have to go ahead and you have to factor. So hopefully you factored this. X minus 5 over x minus 2 is equal to 5x minus 1 over x plus 2 x minus 2. Difference of 2 squares there. Okay, so here we got something that was shared. We got a shared factor. Our shared factor, x minus 2. Okay, so when we write our lowest common denominator, I'm only going to take one of those. I only need one in order to find the common denominator. I only need one. X minus 2, the other shared factor, or the other remaining factor, x plus 2. There's your LCD. Pretty easy, right? Right. All right, last practice problem. Please pause me, and try this one. Okay, hopefully you tried this one. There is some factorization here as well as expansion. Notice how we have x minus 5 squared. That's 1 over x minus 5 times x minus 5. I like to expand it so that you can see each of the factors. And then we again have difference of 2 squares on the far right. X minus 5, x plus 5. So what's shared? X minus 5, that's shared. Anything else? No. Just an x minus 5, a 5, and an x plus 5. So our lowest common denominator, let me list the remaining factors first. 5 times x minus 5. No, plus 5. This one. This one. Yep, x minus 5. And then we have another from the yellow, here's the yellow one, x minus 5. Okay, so there's your LCD. And again, you could use an exponent if you wanted to rewrite those last two binomials. Okay, that is the first part of our lesson, finding the lowest common denominator. Very, very important in this unit. So make sure you keep that in your tool belt. You're going to need to know how to find the lowest common denominator. Something we also have to talk about with rational expressions is we have to talk about domain restrictions. We have to protect a rational expression. I'll write the most basic one here for you, 1 over x. We have to protect this denominator. Protect. Write this in your notes. At all costs. Protect that at all costs. It cannot be 0. You cannot plug a number in there that's going to make that denominator 0. Okay? So remember, this is like the equivalent of like checking IDs at the door. What number are you? Oh, are you going to make my denominator 0? Oh, you can't come in. So in this case, what number is not allowed in 1 over x? What would make that denominator 0? 0. You cannot plug 0. So here, 0 would be a restricted domain value. So here's the idea. Division by 0 is what we call undefined. For example, 6 over 0 has no answer. If you put this into a calculator, you're going to get an error message. This brings up what we call in rational equations, we call these excluded values, because yes, we're being mean, we're being rude, we do not care about their feelings, we exclude these values. Excluded values of a rational equation are values of the variable that create 0 in the denominator. Don't feel bad about excluding them, because they cause problems. They make our life difficult. So don't feel bad. We need to find these troublemakers and exclude them. This means we cannot use any value of x that creates division by 0, since dividing by 0 will pretty much make the world explode. Okay? All right, here's an example. Given x over x minus 8 equals x over 3, what would the excluded value be? If I have the denominator, and I don't want a denominator to be 0, we're only looking at variables, only variables, because over here, is 3 ever going to be 0? No, we know 3 is 3. It's not 0. Over here, I have a variable. This can change. Okay, so what do I plug in here that makes this denominator 0? And that excluded value would be 8. So what we do, we exclude 8. We check its ID. Are you 8? Are you 8? You can't come in. Bye. Kick it to the curb. So let's go ahead and practice some of this. We are going to go ahead and we are going to find the excluded values of a rational equation. Step number 1, here's what you do, and this kind of goes along with the LCD, because if you have the LCD, you just make sure that all of the factors in your LCD cannot equal 0, and I'll show you that. So step 1, factor each denominator completely. Hey, that seems familiar. Step 2, find the LCD. Hey, We kind of did that. Step 3, set each factor that includes x in the LCD equal to 0. You set it equal to 0 and you solve. Step 4, state the values. Okay, so let's go ahead and find the excluded values of each of the equation. And I'm going to go quicker on the LCD just because you should be a little bit more proficient with that learning target here in this part of the lesson. Okay, so step 1, I got to find my LCD. So I need to factor this denominator. This is x minus 3, x plus 3, okay, over x minus 3. Okay, and it looks like my lowest common denominator, I have a shared x minus 3. I have an x plus 3, and then I have a 3, right? X minus 3 is shared here, and then the other two are remaining. So here's my LCD. Okay, so what are my excluded values? Well, I just need to take everything with a variable and set it equal to 0. I need to say, hey, you, x minus 3, you cannot equal 0. And then I just solve this. It's as simple as adding 3 to both sides. We say, hey, x cannot be 3. 3 is a troublemaker. Don't allow 3 in. And then I look over here, x plus 3. I'm going to say, hey, x plus 3, you cannot be equal to 0. And we solve this. I'm going to subtract 3. We get x cannot be negative 3. So here's what we call our excluded values, or I like to abbreviate EV. X cannot be negative 3, comma 3. Okay? Now, I want you to see that this value right here came from that factor, and this value right here came from this factor. So those are your excluded values. Notice I did not touch this positive 3 right here. And I really wish this wasn't a 3. I got to change this example. I wish this was like a 2 or a 7 or something random. That value is not going to change. I don't have to use that. So let's just change it right now. Here. I know you're like, If this was a 7, 5 sevenths. If I change this to a 7 right here. I'll change this to a 7. Get rid of this. Is 7 an excluded value? No! No problems with 7. 7's cool. 7's like the coolest number there is, right? Why is... What's the joke? Why is 5 afraid of 6? I don't know. Let me know in the comment section below what that joke is. I always forget it. I have to like really think about it. I have to write out like 5, 6, 7, 8. Who do we appreciate? Math. Example 2. Step 1, I got to find my LCD. So let me go ahead and expand out my denominator. And I'm cutting a corner here. Now this is me using my shortcuts. I know that this is x minus 1, x plus 1. Okay, so I just like to factor right below. And my LCD, okay, I need shared stuff. So what's shared? X plus 1 is shared. X plus 1, shared. And if this helps you, do this. Shared. X plus 1. Anything else shared? No. These don't match. These don't match. Okay. So x plus 1, shared, and then what's remaining or what's left over? X plus 1. Another x minus 1, and an x. Okay. Okay. So here's what we're going to do. We're going to set each of these equal to 0. We're going to see what makes them 0. So let me start with x right here. Boop. X cannot equal 0. Go ahead and solve. Done. That was easy. I didn't have to do anything. It was already done for me. Okay. X plus 1 cannot equal 0. Solve. X cannot equal negative 1. Hey, check out this one. It's the same thing. It's going to give you the same value. You only need to exclude the number once. So don't write it twice. You already know that that number is not allowed. That number can't hang out with us because we're cool and it's lame. Okay, and then the other lame number, the other mid number is so mid. X cannot equal 1 right here. Okay, all right. So Who are we going to leave out? X cannot be 0, -1, or 1. Okay, maybe you want to put those in order. Probably should. I'm such a terrible math teacher. -1, 0, 1. Okay, leave those ones out. They cause problems. Bloop. Okay, only a couple more examples. All right, example 3 and 4, finding the excluded values. These ones are really simple because there's not much as far as the denominator. We know that the LCD is x and x minus 2. So here, excluded values, x can't be 0. Here, excluded values, x minus 2 can't be 0. So solve that. Add 2 to the both sides. Plus 2. Plus 2. X cannot equal 2. Okay, so what's our excluded values? EV. 0 and positive 2. All right, last example for you here. We have 12 over x plus 5 equals 7/3. So our lowest common denominator is going to be 3 times x plus 5. Okay, well here I only have one variable. I have this number. X plus 5 cannot equal 0. So we'll subtract 5 on both sides. Minus 5, minus 5. We get x cannot equal -5. Okay, so that is our excluded value. What about the 3? The 3 is a 3. It's not going to be 0. Leave that 3 alone. Don't be a bully. You're telling us to exclude values. You're the bully. Yeah, but I have a reason why. Don't judge me. Just listen. Okay, here's some practice problems. You guys are going to try these. You're going to pause me. You're like, thank God, shut this guy up. I'm not even listening. You're going to pause me. You try. You try. Pause. Try. All right, hopefully you pause this. You got to find the LCD. Your LCD is x times x plus 3. And then from this, x cannot equal 0. From this, x cannot equal -3. You set x plus 3 equal to 0. And then you subtract 3 on both sides. And that's what we get. Okay, so excluded values. X cannot equal 0 or -3. All right, next example or practice problem. Pause me, try this. I'll show you the answer here in a second. All right, hopefully for this one you factored x minus 4. This is x minus 2, x plus 2. So then our lowest common denominator is x minus 2. That's shared. There's shared. And then we have a remaining x plus 2. So what are our excluded values? Well, x cannot equal 2. Have you guys figured out that it's just the opposite? It's the opposite value, almost like looking at an h value. X cannot equal -2. So our excluded values, x cannot equal -2 or 2. All right, last. Here you go, pause me. You try this example. Okay, here we go. Last one, the LCD for this example. This is x minus 5 up here. This is x minus 5, x plus 5. Okay, so we get 5 times x minus 5 times x minus 5 times x plus 5. There was a shared x minus 5 right there, and then we had a leftover x minus 5. Okay, so what are the excluded values? Well, x cannot equal 5. Same thing here. So we'll only count that once. Here, x cannot equal -5, and then no issues with that 5 out front, even though 5 is already an excluded value from our domain. Excluded value, x cannot equal -5 and 5. Okay, that is it. Hopefully pretty simple, not heavy lifting algebraic-wise here, just some important ideas. So I want to go back to our learning attention in our success criteria. We want to be able to solve rational equations, and this is the foundational step, learning how to find the lowest common denominator. So, do you know how to find the lowest common denominator? Do you know how to factor polynomial completely and identify common factors and solve the linear equation? Because that's all stuff we did. All right, and then in order to also, we're going to need to understand what values are restricted with rational expressions. These are called excluded values. Okay, so two big ideas discussed in this lesson: lowest common denominator, excluded values. Make sure you like, subscribe, follow RadMathDad on all platforms. I'll see you in the next video. See you later.